Hi everyone, and welcome to this Container Days talk on Kubernetes as a platform for building platforms. My name's Reimer and I'm happy to be your host for the next 35 minutes. So briefly, a few things about myself and about my employer. I'm a principal software architect working at QAware. This Container Days, we are a sponsor of the Container Days. We have a virtual booth, so if you want to talk to me or any of my colleagues, please don't hesitate to drop by. Our headquarters is in Munich, and we have a small office in Rosenheim, which is happens to be my hometown. And this is where I'm broadcasting this video today. In my day-to-day work, I work for large German enterprises. I'm responsible for a large cloud-native development team of around 50 people, and we develop custom software for large German enterprises like German Telekom, BMW, or Allianz Insurance, for example. Now, my personal journey with Kubernetes began back in 2016. I had my first talk on the ContainerCon Europe, which was in Berlin. Here you see my slide deck, and you have the link to the slide deck. And all I showed here is how you can use Kubernetes as a plain container orchestrator. I had a small Spring Boot-based sample application with me that I deployed on a cluster, and I had this KubePad with me, which you see here on the right-hand side. That's a programmable MIDI controller, and that already showed the possibilities of automating Kubernetes and do more with Kubernetes than just orchestrating the containers. So this KubePad was basically programmed against the Kubernetes API to then automate those deployments that were running on the cluster. Every green light you see here is a running pod, and if you click on one of the green lights, then you could destroy the pod, or you could scale up the deployment or scale down the deployment using one of the other buttons. So if you're interested in the source code, it's written in Kotlin. You have to buy one of those Novation MIDI pads. I think it's 150 euros, so, and then you can do exactly the same. Now back then, I was talking about the Kubernetes 101, and I would say 5 years later, it has become a commodity in, I would say, almost every cloud-native development team. Everyone on the team, every cloud-native developer concerned with Kubernetes knows what a deployment is. It knows what a pod is, that a pod can contain multiple containers. You know what a replica set does. You know how to mount config maps inside volumes, or maybe mount the config map as environment variables in your deployment into the pods. You know why you need a service. So all of this has become commodity, and we all know how to write the associated YAML that is required to work with Kubernetes. But that is basic Kubernetes only used as a container orchestrator. And the purpose of the talk today is to show you, possibilities how Kubernetes can be more than just this container orchestrator. Back in November 2017, there's a tweet from Kelsey Hightower where he already said Kubernetes is a platform for building platforms. It's a better place to start and not the end game. And then, not 2 years later, but in February 2019, he tweeted Kubernetes is for people building platforms, and if you are a developer building your own platform, then Kubernetes is for you. Now, maybe you don't want to build your own platform like App Engine or Cloud Foundry, but maybe what you want to do is, to extend Kubernetes with additional capabilities to make your team and to make your product delivery or your application development more streamlined and more easily. So here's my definition, right? This is more of a software developer's definition. Kubernetes is a flexible and extendable platform, yes. It offers several APIs that are application programming interfaces, and also SPIs that can be leveraged to build custom extensions, automations, any DevOps automation you can think of. You can introduce new abstractions inside the cluster, and you can even build complete cloud-native software delivery platforms that have Kubernetes as the base. So here are the topics of today's talk. First up, I will briefly talk how you can leverage Kubernetes to be the cloud-native software delivery platform for your team. How you can use it for this whole process of, manufacturing and assembling, and then finally shipping the software product or those microservices your team is developing. So continuous everything. Then I will talk about the usage of the Kubernetes APIs and associated events that are the basis for any custom automation and extension you want to introduce into your cluster. I will talk you through how you can implement cross-cutting concerns like security, governance, configuration, or any other cross-cutting concerns you could think of using so-called emission controllers. And then finally, we will be extending the Kubernetes API with custom resources and also, operators that then do more with those custom resources. All right, let's jump to the first topic. Now, why is it so important to build your own platform? And you may have realized that too much cognitive load in your teams, it quickly easily can become a bottleneck for fast, slow, and high productivity. And this book you see here is definitely worth a read because this is what they have written. And they are concerned with how can you make your teams more productive. And they have those definitions of different types of cognitive load. So they have this intrinsic cognitive load, extraneous cognitive load, and the domain cognitive load. And this is how they define it. Well, basically the intrinsic cognitive load, that relates to the fundamental aspects and knowledge in the problem space. So us as software engineers, it's the used languages we need to be able to program in. It's the APIs we need to program against. It's the frameworks we're using to build our applications. The second type is the extraneous cognitive load, and that one relates to the environment we will then run and deploy our applications to. So this is all about deployment, it's all about configuration, it's all about knowing the correct console commands and all that. And last but not least, you have the domain cognitive load, and that is actually the one you want to have the most of, because that is the value-added thinking. This is where you produce actual value for your customer or for your product owner or for your team or company. Now, you want to have as much domain cognitive load inside your brain, so that kind of leaves us with what we do with the others. Now, two things you can do. You can reduce the cognitive load or even eliminate those. And elimination is basically possible here at the second type, at the extraneous cognitive load. And if you use Kubernetes naively, and you may have seen that at a few teams, that if you use it naively, they are kind of overloaded with all the, all the this 101 they have to know, and all the console commands, and what is a deployment, and how do I do that, and how do I build it, and how do I configure my microservices. And this is basically where platforms come into play. And what the book suggests is that, you support your streamline teams, so that is the DevOps teams that actually, build the business value. You support them by a platform team, and the platform team is then the key enabler for providing high productivity or enabling high productivity of your streamline teams. So the platform team is responsible to build and operate a platform to then enable and support the other teams in their day-to-day development and delivery work. The platform they're building, it aims to hide the inherent complexity that is associated with cloud-native development and Kubernetes itself, and it hides it and thus reduces the cognitive load for the other teams, so they can, focus on producing value. And this platform does it by, standardizing things or providing self-service capabilities, for example, that the DevOps teams can then use. So the goal is to have fully automated software delivery. Now, that may not sound very new to you, but maybe it does. So Kubernetes can be the core platform for efficient cloud-native development. And one thing I've found recently is, the term developer control plane. And those developer control planes are, highly opinionated assemblies of, different cloud native things and tools and frameworks and technologies that sit on top of Kubernetes that simplify the development. They simplify the deployment. They simplify the operations of those native applications. So make sure to have a look at the developer control plane and the idea behind it on the ambassador side, for example. Now, this is a very highly opinionated stack from the ambassador team, but if you think you don't like it that much, or you want to go your own ways, then of course you can do so. So take Kubernetes as the core platform and then extend it with additional things. For example, a fully remote IDE like Gitpods or Eclipse deployed on a Kubernetes cluster, and all your team needs to have installed on their machine, is a browser to then edit inside the browser and then have, a Visual Studio Code instance that runs inside of Kubernetes, for example. Or you could introduce, Kubernetes native image builds with Canico, or Kubernetes native build pipelines with tools like Tekton, so that the whole CI pipeline runs on the cluster, inside the cluster. You could, introduce GitOps and GitOps-based deployment automation using tools like Argo CD or Flux. And this whole cloud-native application staging and lifecycle orchestration with tools like Captain, and so on and so forth. So make sure you have a look at this nowadays huge landscape from the Cloud Native Computing Foundation to then pick the right tools for your team, for your platform, for your development for your cloud native application development. And you can go even further than that. If you don't find anything on the landscape, you always have the option to combine maybe in another open source a tool to do security testing or performance testing or maybe UI testing, and combine it with basic Kubernetes primitives, and then also put those things on your platform, on your cluster. And I did a few experiments, and those are the 3 links provided here. So the first one is continuous security tests that continuously run on your platform, on your cluster, using and leveraging the Z-Attack proxy that basically, scrapes all the microservices, scrapes all the open API definitions, and then against those open API definitions of your microservices, it will constantly fire security tests against those. Or performance tests, right? Let them run continuously on the cluster. Take a tool like K6, plus a bit of Grafana for some fancy UI, plus InfluxDB to store your performance test data. Add a few primitives like a few Kubernetes deployments, maybe a cron job or a job, and then let that run on a cluster. So that's the second showcase URL provided here. And you can do the same with acceptance and UI tests. Right? Take a framework like Gap, it's a Java-based or Groovy-based test framework, write the test against the Selenium API, containerize those tests, put them on a cluster, let them continuously run, and continuously check the workloads and the applications you have running on the cluster. So that should give you a basic idea that it's nowadays super easy and super straightforward to take Kubernetes as a core platform and then extend it with a few Helm charts, extend it with all those fancy CI/CD tooling, all the test tooling you can think of, put that on your platform and make life a lot easier for your DevOps teams. Let the platform team provide those services to the other teams so they have less work and they have less cognitive load. At the core of all this, all there is the Kubernetes API. And it is really the basis of any DevOps workflow automation and custom extension. Now, in the end, Kubernetes is nothing more than a huge distributed state machine. So anything you do in the cluster, like adding things, modifying things, and deleted things, are kind of state transitions in this state machine. And the Kubernetes API provides you with the means to query the things on the cluster, the Kubernetes objects on the cluster, to watch for changes, to modify things, and to delete things, be it either on known default or custom Kubernetes objects. And the watching bit is that one's really interesting because you can register watchers on any change events that are happening inside the state machine. So things are added, modified, deleted, and they provide you with, a powerful tool, really powerful tool, and the base for any custom automation logic and extension that you might want to program and implement in order to react to those events. Technically, you have 3 possible ways to interact and access the API. The one that most people know is using plain kubectl, but of course you could program against the plain REST API or use your most favorite REST client and call the REST API using HTTP or HTTPS. And you can also access the API programmatically. Now, the Kubernetes community provides several officially supported client libraries for very popular languages like Go and Java and Python and many others. In case there is no official client library, I'm really sure that there is a community maintained client library for all the other languages that are out there, like Rust, for example. If you're interested in having a look at the API docs, they are online under the provided URL here. And let me just briefly show you a few examples how you can interact with the API. So you see this README file here. So the first few lines are you use kubectl, for example, to get the events on anything that happened inside the cluster. So you get the events, you can output them as JSON, you can filter them by any field selector, and then you get back this JSON structure, and then you would have to write some logic to process that output of that event. Slightly more sophisticated and gives you more flexibility at least is, here in this example I used curl now as my REST client, but you could use any other thing like Postman, for example. You issue kubectl proxy that opens a proxy towards the API server on your local host, and then you can pretty much issue all those curl requests that the online documentation tells you that the API and the API server supports. So to query which APIs are there, you can issue those 2 requests here, like those. You can register global watches. So anything that happens, so you can register a watch for any event. You can register a watch from service-specific events. So if a service is added, modified, or deleted, you will be notified, or you can register a watch for pods. You can register namespace-specific watches, also possible, and deployment-specific watches. Now, that would give you technically the means to write a small bash script to do all the automation you want. If you want something more sophisticated, put it that way, and you want to access the Kubernetes API programmatically in your preferred language, like Java in my case, for example, you can also do that pretty easily. So let me quickly show you a small Java program, and all that needs to be done is a bit of boilerplate. Those 4 lines here, they instantiate an API client in Java that is now then able, gives me the interfaces to interact with the API server. Then I construct a pod list object, because in that case here I want to be notified whenever something on a pod changes. And down here, those lines here, they create a watch for this namespace call. And here in line 50, I would then be able to implement my custom automation logic that then reacts to those pod-specific events that happen in the cluster. So that is kind of the basis of all the automations that you can think of. Now, in the early days, already back in 2015, that's a blog post here I referenced, Kubernetes had an early influence on how we build software, and it had an influence on the software architecture itself via the proposed composite container patterns. And those composite container patterns were kind of concerned with implementing things like cross-cutting concerns, circuit breaking, log formatting, log shipping, scheduling, monitoring, configuration, and all that. I will not go in that much in here, but all I want to say is it had a major impact on software architecture, because in the old days we implemented all those functionality, all those cross-cutting concerns inside the application. With that, Well, Kubernetes gave us the possibility to not build it inside the application, but kind of extend the application container with this cross-cutting behavior. Now there is an even more powerful way to implement those cross-cutting concerns, and they are called admission controllers. And think of admission controllers like dynamic plugins for Kubernetes. So think about security, for example. So you can increase the security of your cluster and all of your deployments by mandating a reasonable security baseline, for example, across the entire namespace or an entire cluster. So the pod security policy, for example, is an example of such an admission controller, or the open policy agent heavily relies on admission controllers. You can do some governance things, always interesting for the architects, for example. So you can apply and enforce the adherence to best practices. You can apply and enforce good labeling, or that certain annotations are present, or add them to a deployment. You can enforce that resource limits are set, or modify them if they're not there or too big. And also the liveness and readiness probes. All that is possible. And finally, on a configuration management level, what you can do is you can validate any configuration and any object and prevent basically misconfiguration hitting the cluster in the first place. This is then where the validating admission comes into play. Kubernetes itself, well, it ships with many of those admission controllers already baked in, more than 30. And the ones that are really interesting are the mutating admission webhook and the validating admission webhook. So let's have a quick look how they work. So this is briefly explained, right? An API request hits the API server. So you have the HTTP handler that kind of processes this HTTP request. Then you have some authentication and authorization. Is the caller actually allowed to call that API? Then already comes the mutating admission stage. And what that thing does is the mutating admission webhook controller will call custom webhooks. Those webhooks, well, we can implement those. Your DevOps team or your platform team can implement custom webhooks that contain specific logic, right? So all you need to provide as a webhook is a simple program that provides an HTTP endpoint that is secured via TLS that can be called using a POST request. The request contains the initial object that is part of the original request, and what the mutating webhook then can do is it can send back a JSON patch structure that contains the modifications that should be applied to the original object. So in that case here, for example, I replace the spec replica's value with the value 4. No matter what it was before, I always set it to 4. And of course, as you see here, you can have many of those mutating webhooks registered at that stage. Once the modification has been done, an object schema validation is performed. And then it goes into the validating admission, where you can then finally decide, is this object allowed on the cluster or not? Again, those webhooks, it's a simple HTTP server secured via TLS. It needs to provide one endpoint, a post endpoint that accepts the post request. And then you can implement the logic that decides, hey, will this pod or this deployment or this object, is it allowed on the cluster? Then it will be persisted to etcd, or is it not allowed? And then you can prevent any misconfiguration if you do not allow it. If you are familiar with Go as a language, in the repository I provide you with this talk, there are a few examples there's one example of a validating admission controller and one example of mutating admission, and there's not much code to it. Well, you need to implement a small Go server. Here I register the validate function. Down here I listen and serve using TLS. So that spins up a small HTTP server in Go. And then inside here, the handler function, first up, you do some sanity checking on the request itself. Is there a valid body? Is the request received on the correct URL? And if that's all done, well, you unpack the request payload, which is of type admission review in that case. Then you unpack the initial requested object, which in that case here, for example, I expect it to be a pod. And on that then initial request object, what I can then do is perform some sanity checking. So in that case, for example, this validating controller, well, it checks, is there a liveness probe and is there a readiness probe? If everything good, well, that one container spec is valid. And if not good, then I respond with allowed false, and such definitions, such objects will not be allowed to the cluster. So I don't need much code. You need a bit of Kubernetes YAML to then, register your validating admission webhook configuration inside the cluster. So that is done here on create and update operations for any pod on the whole cluster. Kubernetes will make sure to call my small supplied webhook that is deployed as a plain deployment inside the cluster, and that's it, right? Same here, mutating admission, pretty similar. What the scaffolding is concerned, small HTTP server, and then implement your custom logic. So that is really a powerful means to apply those cross-cutting concerns on a cluster level. You might have heard you can extend the Kubernetes API with custom extensions, and you can introduce new high-level abstractions using so-called custom resources and custom resource definitions. So those are user-defined extensions to the Kubernetes API that are not known beforehand. They allow you to introduce new abstractions for complex application constructs and concepts. I'll give you an example in a second. All you need to do is you need to write a custom resource definition. You need to define the structure of your construct, of your object, of your concept as an open API v3 validating schema definition. And once you register that custom resource definition, Kubernetes out of the box will provide you a lot of default support for all those API features, like creating, reading, updating, or deleting those objects, watching them, discovering them, JSON patch and JSON merge support, admission webhooks, metadata, RBAC, all baked in. Now, when you have difficulties thinking about what is a suitable high-level abstraction, well, here's a simple example. Take this one here, deployment and service. This is what you have to register inside Kubernetes to get something running. But as a developer, you're not thinking in deployments, you're not thinking in services, you're thinking in something called a microservice. So what I want to do is I want to describe my workload as a microservice, and that is the abstraction. All I say here, hey, that is a new microservice, following name, I give it the image I want to deploy, maybe the replicas, the service type, maybe the ports, the rest is all defaulted, and then I need to write some code that makes sure that transforms this microservice definition, this microservice abstraction, that transforms it into the required deployment and the required service. And that brings us now to the last topic, and that is operators. And that is the whole purpose of those operators. You want to do stuff to your Kubernetes, you need to implement some automation that takes your custom resource definition, watches for changes on that one, and then does the required changes inside your cluster or to your cluster. So operators are really are codified ops procedures. They are the codified workflow automation for those, to handle those abstractions. They are our path to zero ops. They enable us to implement auto updating, self-monitoring, and self-healing infrastructure and applications ideally. So this term, coined in the Kubernetes world, it's now been adopted and used widespread in all the cloud native world. OKD, a whole distribution built around the concept of operators. The sealed secrets, to be able to store, encrypted secrets in a Git repository, for example, and then apply those in a cluster. KubeMonkey, WeFlux, this whole GitOps tooling, heavily based around custom resource definitions and the operator concept. And the way the operator works is actually really simple. The operator is basically something running inside the Kubernetes cluster. It's running endlessly in this reconciliation loop. So it's a small Go program or a small Java program. It's tracking and watching any changes that a user might do towards custom resources, or can be any resource. Then Kubernetes will notify the operator about any change events, and then the operator, all it does, it basically makes sure and reacts to those change events and then adjusts the current state of the cluster itself. So it modifies the state machine. It does the required changes. So if a new microservice resource is created, the operator makes sure to create the associated deployment and the associated service or any other thing you might want to do. And in case of error, it just sits there, reconciles until the error is resolved by the user. So that's really simple. And all the operator needs to do is, well, it needs to be programmed against the Kubernetes API. Now, you might think, oh, that's a lot of work. That sounds complicated. Well, and the good news is, well, if you're capable of programming Go, you could, for example, leverage the so-called Operator SDK for, an initial project setup, for super easy project setup and super easy scaffolding. So once you have kind of scaffolded and set up the operator project, all that is left to, well, for you as a developer is you need to implement the custom automation logic and the raw skeleton of this operator and all the deployment magic and all the Kubernetes YAML that needs to go with it in order to, well, deploy the operator to the cluster. It's pretty much all auto-generated by this framework and by the tooling of the framework. So that's really neat. Again, if you're interested, have a look at the associated code in the repository. There are a few instructions, but the online documentation of the Operator SDK is also really good. So this whole project you see here in the operator demo, it's auto-generated. It's all scaffolded. And all then in the end you need to implement is then, for example, in this Go file here you need to put your logic, and the rest, the reconciliation loop. This method is always called when something changes on your demo resource. And that's it, right? And the demo resource, this is here the type. Well, all you need to define is a Go structure that specifies what your custom resource looks like, and then the Operator SDK will make sure to generate the associated custom resource definition as a YAML file. So if you're able to implement those things in Go, then this might be your friend, or it might be your choice. But as I told you, technically you can implement an operator in any language you like. All right, that almost brings us to the end. Here are a few links for you. Make sure to check them out. Many of those examples I just showed you throughout this talk, they are in the first GitHub repository. It's all MIT licensed, so feel free to copy and use it for your own projects if you like the code. If you like to do more with Go and you're capable in Go, have a look at the second repository. There are even more examples on, the microservice operator, for example, can be found in the second repository. This is how you can leverage Go in combination with Kubernetes API to implement custom automation logic. So feel free to have a look at that one. And if you're more in the Java world like I am, I have this experiment repository on my private GitHub account, which is called Graal operators, where I implemented plain operators in GraalVM, or well, in Java with GraalVM, to also show that this is also possible with not that much code and not that much work. All MIT licensed. If you have any questions towards the code, well, definitely feel free to contact me via Twitter. Drop by our virtual booth here at the Container Days. Well, that leaves me off at 34 minutes. I hope you took something with you. I hope you enjoyed it. As I said, drop by our booth. Otherwise, I see you online. Bye-bye.